Hey guys, my name is Brandon, and today we're going to talk about heat. We define heat as the flow of thermal energy. When you grab a hot object, you can feel that thermal energy flowing from the object into your hand. Or if you grab a cold object, you can feel that heat leaving your hand. This flow of thermal energy is what gives us the sensation that an object is hot or cold. This is true even when the object is at room temperature. For example, if you were to jump into a swimming pool or touch a sheet of metal, they may feel cold, but that's only because they're better thermal conductors than the air is. Therefore, once you touch those materials, you will feel a difference in the flow of thermal energy leaving your body. This difference is what gives you the sensation that those objects are colder than the air is, when in fact they're not. With that being stated, it's important to note that it's impossible to know how much heat an object really contains. And the reason why is because the object is at some temperature, meaning that its atoms are vibrating. And atoms are made out of charged particles. So these charged particles vibrating creates waves in the electromagnetic field. This is what we call blackbody radiation. And in contrast, blackbody radiation can induce vibrations within the material as well. So there's an exchangement going on between thermal energy and electromagnetic energy. So even though your system is completely isolated and not allowed to exchange energy with its surroundings, and its total energy is constant, the energy components of the system can fluctuate and exchange with one another. Another way of looking at it is generating heat using friction. Yes, the total amount of energy that I used was equal to the amount of thermal energy I produced. It doesn't mean I had that amount of thermal energy when I began the process. It just means the energy I had, I turned into thermal energy. With that being said, heat usually flows from a region of higher temperature to a region of lower temperature. However, it's not impossible for heat to flow from a region of colder temperature to a region of higher temperature. It just requires energy to do so. An example is your refrigerator. When you put an object in your refrigerator, heat will flow out of your object, and then your refrigerator will dump that heat into your surroundings, which is your kitchen. Because heat is a form of energy, we measure it in units of energy, which is joules. When we're measuring heat as a flow, or energy per second, we measure that in watts, or known as joules per second. Alright, so now for an example. So we have a stove that's producing 100 watts of thermal energy. And we want to know how much thermal energy it produces in a minute. So all we do is convert 1 minute into 60 seconds and we multiply that by 100 watts. And that gives us 6 kilojoules or 6,000 joules. And now you know what heat is. Thank you for watching my video, and if you found it useful, please subscribe.